My name is Tabuzo Chikwanda. I'm going to be presenting on a paper summary for a governing framework on mobile games. This framework leverages on the big.LITTLE architecture. So, as we all know, mobile games are becoming more and more popular each day. So, the problem with these mobile games is that they seem to drain the phone battery. So, this paper seeks to improve that without compromising the performance or the user experience of the game. The paper proposes a governing framework that builds a predictor that selects the most energy efficient configuration using a neural network from the abstract scenes. So, as I said earlier on, the framework leverages on the advantages of the big.LITTLE architecture. So the big.LITTLE architecture consists of big cores, uh, which have higher performance and also uses higher levels of power, and little cores have lower performance and uses less power. So by them working together, they, they almost anything is possible in terms of energy efficiency. So in CMOS logic is the number of is the number of logic switches increases become more and more per second. The active power also required becomes more, and also the leakage also increases with the number of transistors. So we don't want a situation whereby a big core is idling at very low speeds, whilst a little core can handle the same task. So there are different scenes require different levels of power. As you can see from scene one requires less power, scene 2 requires more power. But there's a problem on 25 seconds to 30 seconds. Uh, there's a change, there's a dramatic change, there's a swing. So this is what the govern the framework that is designed seeks to also address, and also be able to sort of tell the expected levels of power for scene 2, rather than going all the way to 13, whilst the scene naturally requires around 10 watts. So this is the other function of the framework. So there are different types of scenes. There are functional scenes, there are abstract scenes, there are performance scenes. So from the abstract scene, we use a model, and then we predict the performance scenes. This is in link with trying to predict what power is required for this activity. So the framework uses Google's TensorFlow to train the model, and trains the model with the collected data from the performance scene generator. So these are the results. On average, the prediction for abstract scenes from training is more efficient with a percentage of 26.7% savings, which is better than the reactive governor and the predictive governor. So in conclusion, the author proposes a novel method to predict the performance demands of the abstract scenes using machine learning. The experimental results showed that the, the past, or should I say the prediction for abstract scenes from training governor performed better than the reactive and the predictive governance. Thank you. Thank you very much. Any questions?